Okay, problem 5. So problem 5 asks, now that we have the ratio of the masses of the Sun and the Earth, what's the ratio of their density? So, density is mass divided by volume, right? So density, there we go. Density is mass divided by volume. And I'm going to write VOL for volume, just to be safe so I don't confuse like a V with velocity or voltage later on. Okay, so what we want to find, stop it, all right, what we want to find is the, let's see, the density of the Sun versus the density of the Earth, sorry. Density of the Sun divided by the density of the Earth, the ratio of the two. Okay, so this is going to be, now the density of the Sun is going to be the mass of the Sun. Dang it, sorry about this, all right, mass of the Sun divided by the volume of the Sun. Okay, so I'm going to write vol with the S subscript. And then divided by the density of the Earth, or times 1 over the density of the Earth. So, why is this so finicky today? Okay, mass of the... Stop it. I hate that little jerky tail. What is it doing? Okay, whatever. That's mass of the Earth. That's volume of the Earth. Okay, so I'm going to simplify this a little and just say it's mass of the Sun over mass of the Earth times volume of the Earth over volume of the Sun. Okay, so, hey, what are the volumes of the Earth and the Sun? Well, these are spheres, right? Or close enough. So the volume of a sphere is equal to 4/3 pi times the radius of the sphere cubed. Okay, so now we're going to get, and I'm going to write all this out even though you might realize that a lot of this stuff is going to cancel. The volume of the Earth is 4/3 pi times the cube of the Earth's radius. And on the bottom, you're going to have the volume of the Sun, which is 4/3 pi times the cube of the Sun's radius. Okay, so what should be apparent now that I've written out like this is that a lot of this stuff will cancel. In fact, the 4/3 pi's will all cancel, right? So now we're going to get, and this is still equal to this density over here, right? So this over here is equal to, it's going to be mass of the Sun over mass of the Earth, and we found that ratio in the previous problem, right? And then it's going to be times radius of the Earth over radius of the Sun, and each of these gets cubed, right? But I'm just going to pull that cube out and do it like that. So really, all you have to do is know the ratio of their radii, which is this thing, and the ratio of their masses. Take it properly, and let's see. So the radius of the Earth was 6,371 kilometers, and the radius of the Sun was 696,300. So let's see. 6,371 divided by 696,300. And I'm going to take that whole thing and cube it. And then I'm going to, that's right, and then I'm going to multiply that by 333,500. Maybe I should get a calculator I can pop up on top of this thing. I don't know. I'm just brainstorming here. Okay, and so the ratio, interestingly, this ratio, density of the Sun to density of the Earth, density of the Sun over density of the Earth is 0.255. If you want to take one more digit, it'd be another 5. So the Sun's density is about a quarter of the density of the Earth, which means the Sun is, well, less dense than Earth. A cubic meter of Sun, on average, is going to be only a quarter of the mass of a cubic meter of the Earth. And I guess what I sort of meant by that last bit is, does this seem more like a solid, liquid, or a gas? And I think the answer is a liquid. The Sun is, so this is just sort of to give you an idea of what 16th century astronomers could figure out, or 17th century astronomers. They would conclude, oh, it's probably a liquid, which is, something worth knowing. It's not really gas or solid. looks like a liquid. And I don't actually know how accurate that is the interesting thing. I think the sun actually has a sort of a very dense core, and then as you move out, it gets progressively less dense. I don't know whether any of it is really truly liquid, or if it's just an extremely dense gas that's sort of heavily compacted by gravitational pressure. Anyway, there you go. That's the answer to problem 5.